Hello everyone, so in this video let us talk about the first three problems from the latest Codeforces round 811. So let's start. The first problem is everyone loves to sleep. Yeah, it is true. So what like Wald, if I pronounce it right, likes everyone else loves to sleep very much. Now they have given some constraints, I'll tell you in brief. So what it actually states that there are n clocks and Wald has set all the n clocks according to some time. So and the time is of 24-hour format. So let's say one clock will rank at some time, let's say 13:0, which means 13 minutes, and 13 hours 0 minute, and 23 hours 59 minutes, and so on. So they are like n clocks, and like Wald sleep at h hours m minutes. So you will sleep at any point. Now you will just tell us what is the next clock that will ring. So like from the point you sleep to the point the next clock rang, how much time will you able to sleep in that moment? That's the problem. So you have to also output the same, like in the same format only, like the hour and minute type of thing. So which means that you just have to tell how much time you have slept. So you have to just calculate the number of time, because the time is very small. But very small, I means that you can like literally just do a very brute force way instead of like finding out the difference and then writing on some complex things. What you can actually do is that first convert everything into minutes. Okay, so you are given hour and minute, so hour into 24 will give you minutes, and just add it into minutes, so you will get the exact minute mapping. So let's say that you have h hours, so let's say h hours and m minutes. So what you're going to do is h into 60 plus m will give you in minutes, okay, the exact values, and then you can just store out all of these values in some map or set whatever you want, so that you have now sorted them out. Now what you'll do is, let's say you slept at h comma m, convert this also into minute. So let's say it is h into 60 plus m, and then keep on incrementing the time one by one. So let's say now at this time, whether there's a clock, now plus 1, whether there's a clock at this point, plus 2, plus 3. So you can just take a variable that is t, keep on doing while loop over that, and just check that whether at any moment of time this t or this value hits a value in the map, because map is storing all the values from the clock. At any moment when it hits, you have got the time clock, so you have got the time, just convert it back. So just take t divided by 60, and t mod 60 will give you the values in the time and our clock and the R value, and just print it out. That's the thing. Total just problem here is that you have to do in circles. By circle I mean that, let's say like if you slept at, let's say 11 p.m, or let's say you just go in 11, or let's say 23:00, and the next clock is at, let's say 2 a.m, so let's say 2:00. So you have to when you keep on incrementing the time, it will go 24 hours, and then you have to move back to 0,0000. So what you eventually do is take the mod. So whatever value you have calculated here, like this h into 60 plus m plus this t, just mod it with 24 into 60. Okay, this is the total number of time which can minutes, because everything is in minutes. So 24 into 60 is the total number of minutes which I can get in a complete day. 24 hours into 60. Keep on mod, whatever you're taking this value, do a mod with 24 into 60, so that when it exceeds 24 into 60, it will get 0, and then keep on incrementing. So you will eventually get the total. That's all the logic here. Nothing much complicated. It's just very very standard and very A type of problem as well. So let's move on to the code part now. So this is the input. We have created a map. This is h comma m, the time we slept. This input all of that. Convert h into 60 plus m by the time of every clock, incremented by 1, which means that how many clocks we have at that point. And this is the time which will keep on incrementing. We'll do a while loop until this particular, so we will just check that whether any ith point, any t from let's say t increment 1 to from 0, everything, if that present in map, if it's present in the map, then what we'll do, we have we'll break out at this point. If it is not present in map, we'll keep on doing that iteration. If it is present in map, we'll break out. We'll do 24 to 60 mod again, because if it is out of if it has incremented our range, it this mod will get us in our range between this time only, and then the answer is divided by 60 and mods, and that's overall. The second problem is, this is the very simple problem, and this can be A also. The problem statement says that Polycarp has presented with some sequence of A length n numbers, And now what you'll actually have to do is that you are given an n numbers, and in each step what you can do, you can remove out the first element from the sequence, and each in each operation you can remove one operation, one number. So you will keep on removing the leftmost element, okay, until all the elements remaining are unique or distinct. Okay, so that's the whole problem, that you have to just remove out some element from the left hand side such that all the remaining elements will be distinct or unique. Now how you can do that? So the very best solution for that is, like, whatever sequence you have, just move from right to left over this sequence and find out the first point where it is repeating. Okay, so because I want so when I remove all the numbers from the left hand side, only right hand side elements will be left. So if you just divide out the hele into some like imaginary left and right half, if you remove out the left half, all the right half elements will be remaining, and that will be distant. So what I'm trying to say here is that I have some numbers, let's say 1, 3, 4, and let's say 4 and like 3. So if I remove out all of these numbers, then all the remaining numbers are like distant. Why? Because I just find out the first occurrence of 4. Okay, because before that I have to remove all the elements, because even if there is some occurrence, let's say 3 is also occurring. Okay, but if I remove this, like if I just remove the first part, still there is occurrence. Remove this, now there is no occurrence. So I have to keep on deleting out some elements. So what I can directly do is I'll move from right to left, find out the first occurrence, like the number that is already occurred in the back. Okay, for that you can use a set, like keep on maintaining a set over all the elements from moving from right to left. Whenever you find out the same element again, you know that at this particular point of time you have to delete all the elements before that. So what you'll do is that if this is the index I, okay, all the elements that is from here to here, so I plus 1 indexes, because the index is from 0, so I plus 1, which means that all the indexes from 0 till this number, all the elements should be deleted. So the answer is I plus 1. Like if there is if it doesn't match, like all the elements are distant, the answer is 0, because you don't have to remove out any. That's the whole problem, like solution. Nothing much complicated, it's very simple as well. So I'll show you the code part now. What it goes like this is that you have showed all the elements, you have to make a set and then iterate over from back to front, that is n-1 to front, and just check out that whether the same element again exists at any moment of time at any ith point. If it is not, then keep on inserting the element to the set. If it exists, then the answer is I plus 1. If we just came out of this for loop without anything, then the answer is 0, that no element should be like deleted. Everything is distant. The next problem is minimum varied number. So what you're actually trying to say is that you're given a number, like you have to find out actually a minimum number such that the sum of all the digits in that number should be equal to the given this number, as well as all the digits should be distant. So you're given some number, you have to make a number such that the sum of all the digits in the formed number should be equal to this, as well as all the numbers should be distant. Now because all the numbers should be distant, the maximum case can be like the number you can form is like this 1 2 3 4 5 6, and because it's a minimum number, you might say that I can like reverse all these positions or change these positions, then also it's valid number, the total sum is same. But yeah, you have to find out the minimum, so you have to like put it always in a decreasing order, like or you can say from left to right increasing order. Okay, so minimum number such that the total sum is equal to this. So because in this scenario, as you can see that the total sum, the maximum, because you have to only choose distant numbers, the maximum is that you can put all the numbers 1 2 3 4 5 till 9, because these are the like distant digits. So in that scenario, total sum becomes 45. So that's why the total sum of this will go from 1 till 45 only, like it is not like anywhere very large. That is why it's a very small number, that because the maximum case scenario is this. Now what's the ways, like the best case scenario for this problem is that it's a very brute force type of problem as well. So what you can actually do is that if I just take one example, that is, let's say take 20 and let's say 10. So let's say 20 first. Okay, so because I want to find out the minimum number, I'll start from the very back, like the very bigger number. Let's say I want to put 9 first. Like, can I put 9? Yes, I can put 9, because 9 is like smaller than 20. I can put 9. If I can put 9, then the remaining digit is, let's say, 11. Now I cannot put 9, so I can put 8. I can only put 8 if this number is larger than 8. Okay, because if it is like, let's say like if I put 8, then this number will become 8 9 10 11 3. And now because it has already 3, I will only put 3, because I cannot like put 7 here, because it is already smaller than 3. I get the answer. Pretty simple. I hope you get the point. So what we're trying to do is that we will be subtracting all the elements like 9, 8, 7, and at the point when we are not able to put any number, like the number is already very small and it is like a singular digit, we'll directly put that number and we have got the smallest digit. So what we are trying to do is that I will be appending in the in the reverse manner. So the first number that we got is 9 and 8 and 3, but in the end the answer is actually this. So we have to reverse it out because we want the smallest number. So 3, 8, 9. That's the overall logic for this problem. Nothing much here. So let us move on to the code part now. So what we are trying to do here is that we have taken both of n as well as the string that we want to form. The initial number, like the very large number that we want to start with, is 9. And we'll keep on doing this while loop until there is some number left in n, because the total sum we want is n. What I'll do is I want minimum of either n, because I can either choose the number that is n or this n value, that is the digit I can put. So minimum all of them. So let's say the number is 20. So 20, 9. The answer is minimum is 9. So I will put 9. So I will push that 9 in this answer that we are building, 9. I will subtract 9 from this n because now 9 is used as a digit. So what is the next numbers that are left for which the total sum be equal to n? So like 9 minus 20 minus, let's say 9 equal to 11. So now the total sum should be equal to 11 because we have inserted 9 already. And now because we have used 9, I will now make my 9 minus, which is like 8. So now I have two options. Either I will use 8 or the number that is left. So let's say 11. So I will now find out the minimum. So let's say it is still 8. So I will put 8. I will insert 8. I will now subtract like 11 minus 8, that is 3. So, and I will also subtract this 8 by 1, that is 8 becomes 7. So I have now two options. Either I will put 7 or I will put 3. So it is 3. I will put 3, subtract 3 by 3, it will become 0. This for loop, like this value will be break. And now because we inserted in the reverse manner, we have to reverse the whole string and just print out. Pretty much simple as it is. So all the code will be in the description of this video. Coming on to the time complexity as well, this is O of like while loops O of n, you can say. This is also O of n. So this is where we're using like searching in set also, so of n log n, you can say, because searching in set will take log n also. So for every time we are searching in set, so of n log n. And this is just constant time because the time amount is very constant, so we are just doing in a very constant time. So it's looking for loop, but for loop is very small, constant time. Yep. So that's the overall logic and the code part and the time complexity is for all the problem. Thank you for watching the video till the end.